talk about communities. We're going to talk about how to analyze communities in a ordination. And ordination is what we call a multivariate data analysis approach. And we call it this way because there are multiple y values. So in the past, when you've asked questions about communities, you may have asked questions like, are there more species? In community A or B, for example. So if you have two communities, one might have more species than the other. And so you can ask a question from sampling about whether one species has greater species richness. You can also ask a question about diversity, because of course we know that number of species is not all there is to diversity. It's also about how equally space is shared among the multiple members of a community. Oops. Both of these approaches, both of these variables are really important to ask questions about. They tell you a lot about your community, but they don't tell you everything. They don't tell you the community fingerprint of that community. And in both cases, these would both be a single y variable. So in this case, this might be richness. In this case, this might be diversity. And we would actually reflect those with measures of richness, sometimes represented by S or R, but probably more commonly by S for species richness. And for diversity, we might use something like Shannon's H prime, which you've covered before, hopefully. But both of these are taking an index from the entire community, but they don't tell us everything. So for that, for more on this, let's look at a graph. Now, if I have a simple graph where I put species A on the x-axis and I put species B on the y-axis, when I go out and sample a number of communities, let's say I have 3 communities here, then we can explain on this one graph how the community differs in terms of species A and species B at the same time. This community here has this amount of species A and this amount of species B. So if this was 10, this might be 1. This community also has 10 species A, if that's what that mark on the x-axis is. But then on the y-axis, they have more species B. Let's call that something like 8. Finally, this sample here has a small amount of species A, let's say it's around 2, and a larger amount of species B. So all of these individual samples differ in terms of species A and species B. And if the x's represent location 1, let's put a little key here. X is going to be location 1. whatever that is. Let's just pretend we have one location where we've sampled communities for these two species. Just going to redraw this so it's a little easier to see. Then we might have another place, location 2, where we sample again. And let's say we go to location 2 and we get data like this. In this case, it turns out to be a relatively simple thing to look at because in all cases, location 2 has smaller amounts of species A and species B. And so we can say it's different in both species A and species B. Both of these sites have both of these two species, so they have the same species richness if there were only these two species, but they have different amounts, different relative amounts. The picture can get more complicated though. Where you could have a situation like, let's say, one ends up here, and another group of samples ends up, over here. Both of these communities would have a high amount of one species and a relatively low amount of the other, So they might have similar evenness, but distributed between two species, two different species, where species B is abundant in location 2, species A is abundant in location 1. And they have a similar spread among their data, they have the same richness, same number of species, probably similar evenness, but clearly the communities are different. So here's one community here, and then we have one community here. This is where ordination approaches come in. So it's simple to do this for two species, but it gets more complicated when we start thinking about more than two. For example, two species, we can graph it out, but let's imagine instead this is a 3D plot. And in a 3D plot, of course, we can do the same thing that we just did before, only we have to tie each of these sample points not only to an x and a y axis, but also to a z axis back here. And that becomes more complicated. So that we can do that in the 3D graph still, but once we get to 4 dimensions, 5 dimensions, that is 4 or 5 axes, it becomes more difficult to represent on a single graph. So ordination approaches allow us to represent data like these for more than 3 axes in a single 2-dimensional plane. And that's basically what an ordination is doing. It's representing your community data that has more dimensions than just 3, like 3 species, where a dimension is for every species or every item you're analyzing. And it's compressing it down to a 2-dimensional plane.